Okay, welcome back to my channel. In our last video, we're talking about solubility, and we did some solving, some questions were dealt with. This time around, we're looking at electrolysis. Electrolysis is a familiar topic, and so we have some questions we're going to solve. But before I venture into the questions, or before I solve those questions, it's important I do a little justice on what electrolysis is all about. What's electrolysis? Electrolysis simply means the chemical decomposition, or what we call chemical decomposition of substance when there's a passage of electric current through that substance. Like normal human being now, if there's an electric current that passes through you, you discover you're going to check. So when there's a current passing through a substance, that's what we call electrolysis. And our calculation is going to be based on the first law and the second law. For the first law, it states that the mass of an element liberated or deposited or dissolved is directly proportional to the quantity of electricity that is passing through it. And here you have this directly proportional to the quantity, which we now have ZQ, where Z represents the chemical equivalence, is a constant, and we call it chemical equivalence. You'll be given, if you are to solve your exam, or you might be asked to find why other parameters are given to you. Here we have Q to be equals to is now ZIT. So we have something like this. It's important you know this. It's important you know this. If I make Z subject to formula, I'm going to have mass over current. Z, therefore, can be mass 1, current 1, and T1, mass 2, current 2, and T2. You can be asked to find any of this. One can be given, so you make the other subject of formula. Are you following, students? Yes, sir. Okay, so that's what we have there. Now, if we are to handle this in physics, there's a way I would have handled it, but that's a different thing in physics. I would have related mass with density and volume. You remember now? So I would have just said, begin to derive another formula entirely, where you now bring in thickness, you bring in area and all that. I don't know if we have to do that just to put it in, or we should concentrate on our chemistry. Okay? Okay, we should trash it along. Should we? Yes. Okay, so my students have just said we should trash the physics on along. Okay, so let's trash it along very quickly. Okay, so looking at what we have now, if we incorporate the knowledge of physics into this, so we have ZIT. Now, from physics, density is, so mass is density times volume. So we have density times volume equals to I this, from what we have here. You can see what I'm saying. Density is times volume. What's volume? Area times thickness. IT is a thickness. That's volume. Equals to ZIT. Here you can be asked in your physics, it's in past question, to find the thickness, which will now give you ZIT over density times area times what? Over density times area. You can be asked to find the time. So that takes us to Faraday's second law. I'm sure this is very clear, students.
Yes, sir.
Okay. So it takes us to Faraday's second law. Faraday's second law states that Faraday's second law states that the quantity of electricity passes through a solution of different electrolytes. What happened? And the relative number of mole is inversely proportional to the charge on the ions or electrons. Now, I don't know whether you prefer E or C. Which one are we using?
C.
C. Okay, so you say you prefer C. So the relative number of mole is inversely proportional to the charge of the ion. So we have N equals to K over C. So that my K is N1 C1 over N2 C2. Do not forget, N refers to the number of mole, relative number of mole or mole. And this C refers to the charge of the ions, the valence ion. Are you following now?
Yes, sir.
Now, do not forget that this N that we call mole is mass over what? Over molar what? Over molar mass. Are you following at all?
Yes, sir.
Okay, so we have our N equals to mass over molar mass. That's clear enough. Now we can now bring in what we have here so that we have C1 M over capital N 1 equals to what? C2 M what? 2 over capital. Now I can decide to make anyone what? Subject of formula. Are you following?
Yes, sir.
N is the mass over this. So I have this. Now, the final formula we like to bring out from here, which is very pivotal, is N mass over molar mass is equals to quantity over charge multiplied by Faraday. Please, students, put this in your head. Again, M is equals to capital N IT over CF. Another one you need to commit to your memory. Now, what happened here? In this case, your N, the small m is your mass, the mass of the element, the molar mass of the element, the quantity, it refers to the quantity. C refers to the what? The charge. Charge in what? Coulomb. In what?
Coulomb.
And then F refers to Faraday. And 1 Faraday is 96,500 coulomb. We have what again? I, and that's current in ampere. And T, time in seconds. Any question? Is it very clear?
Yes, sir.
Very. Now, we cannot solve question now.